Sorry, so 3 problems. Problems per minute. And so we could solve that by putting it in the equation. Y is equal to 3. 3 is the number of problems per minute, so it's a constant x. And then in the problem, we're given 24 math problems. So that was our x. X over, oh, no, that was our y, sorry. Y divided by x. Y divided by x. And so therefore, the y is the 24 math problems. 24 equals 3x. And so we're dividing both sides by 3. 24 divided by 3 is 8 equals x. X is the number of minutes. So set it up as a proportion, set it up as an equation. That's why we have our equations. Okay. So similar figures, 2 figures with congruent angles and proportional sides. So you set up a proportion using the corresponding parts, use cross multiplication or shortcut to solve for the missing measurement. Okay, so corresponding parts. So 2 is corresponding to 4 and 6 is corresponding to x. And so we have 2 and then the 4 are corresponding, and then 6 and the x are corresponding. So 2 times x is 2x. 6 times 4 is 24. And divide both sides by 2. So x is equal to 12. Okay, and we can see that a shortcut. The other way to do it is we can say from 2 to 4 we're multiplying by 2. 2 times 2 is 4. And so if we're multiplying on that side by 2, then 6 times 2 we'd have to do as well, and 6 times 2 is 12. So that would be our shortcut way. Okay? And then the man in the shadows. So the x and the 6 are corresponding because those are the height, and then the 8 and the 2, are corresponding. Those are the shadows. So this is for the tree, and this is the person. Okay, so 2 times x is 2x is equal to 6 times 8 is 48. Okay, so divide both sides by 2, and x is equal to 24. Okay, so the height of the tree is 24. And you could do the same thing. So 2 times what gave me 8? 2 times 4 gives me 8. Okay, so 2 times what gives me 8? Those are the corresponding, so times 4. And if you do it there, you'd also have to multiply here, times 4. So 6 times 4 is 24, because they are proportional. Probability. Okay, so probability is the section of math that tries to answer the question, is something probably going to happen or not? And so in theoretical probability, in theory, we have P and then the event. And so in order for theoretical probability is we put the number of times the event can occur out of the number of possible outcomes. In experimental probability, it means you're actually doing it. It's an experiment. And so you have the number of times the event occurred, and then the number of trials or experiments. So unless you actually do it, you can't do experimental probability. So using a fair number cube, meaning a 6-sided cube. So numbers 1, 2, 3, 4, 5, and 6 are the possibilities. And so in theoretical, it's saying P, so the probability of rolling a 2. And so you only have one 2 on a 6-sided cube, and then the number of possible outcomes, and there are 6 outcomes. So you have 1 out of 6 chance is your theoretical probability. And then an experimental probability, so here's their rules that they actually tried, the probability of getting a 2. And so they rolled a 2 twice, so 2 times. And out of how many, the number of trials and experiments, they did it 6 times. They rolled the dice 6 times. And so 2 out of 6, 2 would go into 2 once, and 2 will go into 6 3 times. So in this case, you had a 1/3 probability. Okay. Yeah. Lines, angles, transversals, etc. We did not work with transversals. You will work more with those next year. But we have done most of the rest of the information. So, lines, angles, transversals, and other geometry. Parallel lines. 2 lines intersect in the same plane that do not intersect. So, this line and this line would be parallel. And then a transversal is a line that intersects 2 or more lines. So in this case, this is our transversal. Okay. Vertical lines are opposite and congruent. Angles in the intersection of 2 lines. So examples 2 and 3. So angle 2 and 3 are vertical angles here. Okay, 1 and 4 are 5 and 8, 6 and 7. Okay, corresponding angles are 2 congruent angles on the same side of the transversal in the same position as they are on the parallel lines. So we haven't really talked about this, so we'll go quickly through that. So corresponding angles, so angle 1 and 5. So these are corresponding because they're in the same position on that transversal, and you can see they look like they do have about the same or they do have the same angle, and so they're congruent. And then adjacent, they share a vertex and a ray. So examples is 6 and 8, so angle 6 and 8 are adjacent. The fact that they're adjacent doesn't give us any value whatsoever to those angles. However, they do create a straight line, and so they're also supplementary. So if angle 2 equals 50 degrees, so angle 2, they're saying here, is 50 degrees. Okay, then angle 3 is also 50 degrees because they're vertical. And then 6 and 7, because 6 is in the same position as 2 is on the line, is also 50 degrees. And because 7 is in either the same position as angle 3, or because it is vertical from angle 6, it is also 50 degrees. Okay, so also angle 1, 4, 5, and 8. So 1, 4, 5, and 8. So 1, 4, 5, and 8. So what would be the measure of angle 1? So 1 and 2, they make that straight line right here. Okay, so 180, 180 minus 50. Leaves me with 130. So angle 1 is 130 degrees, and then the rest of those are also 130 degrees. Complementary and supplementary, these are the ones that we did talk about. So complementary, 2 angles whose measures add up to 90. Supplementary, 2 angles whose measures add up to 180. So if we're looking at this one, we know that this is going to be complementary. So complementary angles, talking about this. Supplementary angles, talking about these. So that means 62 plus x has to equal 90. Subtract the 62 from both sides, leaving me with x is equal to 28 degrees. Okay, y plus 77 equals 180 because they are supplementary. They're making a straight line. Subtract the 77 from both sides. So y is equal to 103 degrees. And that does look like it is a possibility. Looks like it's a good answer. Correct answer. Okay. Okay, in triangles, we need to add a little information here, which is your triangle inequality theorem that says any two sides sum must be greater than the third. Okay, and then we also had that a triangle's angles are equal to 180 degrees total. Okay, and then we just have our different types of triangles. Isosceles has two length sides that are the same measure. Scalene, none of them are the same. Equilateral, they're all the same. And then a right triangle has a right angle. In a circle, information we needed to know about a circle is a set of points that are all the same distance from the center. That is the definition of a circle. We need to know that pi is equal to 3.14. We need to know how to use the formulas. C is equal to pi times d, and C is equal to 2 pi r. So in order to find the distance around, we could use either of those two formulas. And then lastly, area is equal to pi r squared. So if we wanted to find the distance inside of a circle, we would have to use that formula. And then three-dimensional shapes. We have a cube, a rectangular prism, sphere, cone, cylinder, and pyramid. We concentrated on a rectangular prism and a pyramid. And then finally, cross sections is a section that refers to taking a slice of a three-dimensional object and determining the shape of the slice. Example, slicing a cylinder. So we didn't really concentrate or look at a circle, or not circle, cylinder. But whenever something is sliced parallel to the base, determines the shape. So for instance, the base here in the first one is a circle, and so when you slice it parallel to the base, it did come out as a two-dimensional shape, which was a circle. If we looked at a rectangular prism, if we sliced it this way, it would be a rectangle. In a pyramid, same thing. If we sliced it parallel to the base, it would depend. If it was a square pyramid, it would be a square, and if it was a rectangular pyramid, it would be a rectangle, just depending on whatever the shape is. And so that's our two-dimensional shape that happens when it is sliced, just called a cross section. Okay. And that is it for your booklet. Make sure that you are keeping up with your booklet. You get to use it, and it is a great reference.